This is from the Department of Chemistry, University of Bahrain. Welcome to Chemy 101 lab. Today we are demonstrating experiment number 8, which is separation of a mixture by paper chromatography. The aim of this experiment is to separate, detect and identify the components of a mixture by paper chromatography. Now, for any chromatography, you have a stationary phase and a mobile phase. For paper chromatography, the stationary phase is the chromatography filter paper and the mobile phase is a solvent, which is a mixture of acetone and HCl in the ratio of 9:1. So the first step is to prepare our stationary phase, the paper. So what I have done here is I have measured 2 centimeters from the bottom and drawn a straight line using a pencil, and I have measured 1 centimeter from the top and drawn a straight line using pencil. Now on this base line, which is the 2 centimeter distant line, I have put 5 equidistant spots. Almost they are equidistant, and I have marked them as Ni2+, Cu2+, Fe3+, MIX, which stands for mixture, and we have unknown, and we are using today unknown number 3. Now to these points where we have put the dots, now to these dots we are going to add the corresponding chemicals. As you can see here, this is the nickel solution, this is the copper solution, this is iron solution, this is the mixture, which is a mixture of nickel, copper and iron, and this is our unknown number 3, and we don't know what are the components present in it. Our aim is to identify the components present in the unknown. So now, using a capillary pipette, I'm going to spot these chemicals on the paper at these points. So at nickel spot, I'm going to spot the nickel chemical. On the copper spot, I'm putting the chemical copper. Similarly for iron, Fe3+. Mixture. And finally the unknown. We have taken here unknown number 3. Now we have to let this to air dry, so we keep it for air drying. Now while this is getting dried, the spots are getting dried, we are going to measure the solvent, the mobile phase. So I have measured here approximately 12 to 13 ml of the solvent, the mobile phase, and I'm transferring it into a beaker. Next step, I have here filter paper. I'm going to line the beaker with this filter paper to saturate the environment with the vapors of the solvent. Now once this is done, and once the spots are dry, the chemical is dry, we are going to place the stationary phase into the mobile phase such that the paper does not touch the beaker or the filter paper. Okay, now once you place it, you can just close it with a watch glass, and then we have to wait till the solvent travels up and reaches the solvent front, that is the line at the top. This is the solvent front. As you can see, the solvent is traveling up the paper. Now this is ascending chromatography because the solvent is moving up along the paper because of the capillary action of the paper. So as you can see, when the mobile phase or when the stationary phase, the paper is kept in the solvent travels up through the paper because of the capillary action, and one has to ensure that when you place the stationary phase in the mobile phase, the level of the mobile phase must be below the 2 centimeter line. That is, the line where you have put the spots must be above the solvent. So that is why I have taken only 13 ml of the solvent. Now as the solvent travels up, the components also start to migrate, but different components are going to migrate at different rates, because this depends on the affinity of the component towards the stationary phase and the mobile phase. A component which has more affinity towards the stationary phase than the mobile phase will travel at a slower rate compared to a component which has greater affinity for the mobile phase than the stationary phase, because that component which has greater affinity for the mobile phase will travel at a faster rate. So now we have to wait till the solvent reaches the top line or the solvent front without disturbing the beaker. Now this is the point at which we remove the paper, because the solvent has reached the top line, and then we keep it for air drying. Okay, so now when the solvent reached the top line, I remove the paper from the beaker and I have kept it here for drying on the watch glass. So now it is almost dry. I had kept it for a few minutes and it is dry, but now I cannot see the separate spots. So now we can see that the spots are very weakly colored or almost colorless. So we have to develop the spots, for which we are going to use some developing reagents. So to do the development, we are coming to the fume cupboard where we have the developing reagents, concentrated ammonia and dimethyl glyoxin, which is an organic reagent. Okay, so what we are going to do is, first we'll treat the paper with ammonia vapors, because where there is copper will react with concentrated ammonia to form a blue colored complex. Hence, wherever there is copper spot, there you will get blue colored spot. On the other hand, the nickel will react with the dimethyl glyoxamine ethanol reagent to form a pinkish red band. That is again another complex formation. And for iron, Fe3+, we don't need any developing reagent because it naturally produces a reddish brown or rust colored spot. So first we will treat it with ammonia vapors. This is concentrated ammonia, hence we are performing this in the fume cupboard. You can see that since there was copper here, you can see a blue spot formed there. Next, we are going to treat it with the nickel spots with dimethyl glyoxin. So I have did this swab in the dimethyl glyoxin, and we know there is nickel here, and the mixture is actually a mixture of nickel, copper and iron. And we also put it for unknown to see if there is any nickel in there. Now you can see that wherever there is nickel, we have a pinkish red band. Where there is copper, there is a blue spot. Where there is iron, we have a rust color, and the mixture has nickel, copper and iron. And unknown 3, there is a pink band as well as a reddish brown band. So now once the spots are clearly seen, we can find the midpoint of these spots. So for nickel, I have marked around it and I have found its midpoint. For copper, which is given by the blue spot, I have marked its midpoint. For iron, which is given by the rust color, the midpoint has been marked. And in the mixture which had nickel, copper, iron, we can see that the components which were together has now got separated. And the unknown, we can see 2 colors, that is, we can find a pinkish red band and a rust colored band here. Now, using these distances, we can find retention factor RF given by the equation. Retention factor is equal to distance traveled by the spot divided by distance traveled by the solvent. To find the distance traveled by the nickel spot, we measure using a ruler the distance from this spot to this spot. So RF for nickel is equal to distance traveled by the nickel spot divided by the distance traveled by the solvent. That is, if you remember, we had allowed the solvent to travel till the solvent front. So the distance traveled by the solvent is measured from the bottom, the baseline, to the solvent front. Similarly, RF for copper is distance traveled by the copper spot divided by the distance traveled by the solvent, and thus you can find for the iron spot. And for unknown, since we have 2 spots, we can find the RF for spot number 1 and RF for spot number 2. Comparing the RFs of these unknown spots with the RFs of these known spots, that is nickel, copper and iron, you can identify the components which is present in unknown number 3.